everyone, my name is Kayla Rodriguez and this is my homework assignment number 6 covering chapter 20. For this presentation, I will be designing I will design 5 aerobic endurance training sessions for scenario C from chapter 17. This athlete is a 17-year-old male high school cross-country runner who is beginning his end season. For this assignment, we are assuming that the athlete has a resting heart rate of 48 beats per minute, VO2 max of 75 milliliters per kilogram per minute, and a lactate threshold occurring at 70% of his VO2 max. So in this presentation, again, I will discuss long, slow distance training, pace or tempo training, interval training, high intensity interval training, and the fartlek training. For each method, I will explain the duration, intensity, target heart rate, rating of perceived exertion, work and recovery periods, and then number of seconds. So before designing the sessions, I first need to calculate the athlete's estimated maximum heart rate and heart rate reserve. So I have my calculations right here. So using the age predicted maximum heart rate formula, I subtract the athlete's age from 220. 220 minus 17 gives an estimated max heart rate of 200 beats per minute. Then I will calculate the heart rate reserve, which would be the equation heart rate reserve equals heart rate max minus heart rate rest. In this case, the heart rate rest is 48 and the heart rate max is 203. So 203 minus 48 equals 155 beats per minute. And then to calculate target heart rate using the Karvonen method, we have this equation, which is heart rate reserve times intensity plus heart rate rest. A 70% heart rate reserve, I multiply 155 times 0.70, which is a 70% heart rate reserve, and I add 48, producing about 157 beats per minute. It is important to understand that prescribing 70% of heart rate reserve is not identical to prescribing 70% of maximum heart rate. 70% of maximum heart rate would only be about 142 beats per minute, while 70% of heart rate reserve produces about 157 beats per minute. So for this presentation, I will use the Karvonen method as my primary target heart rate calculation. So our first training method is long, slow distance training, commonly abbreviated as LSD, not the drug. According to chapter 20, long, slow distance training is generally performed continuously for approximately 30 minutes to 2 hours at an intensity near 70% of VO2 max. This method does help improve aerobic endurance, exercise economy, lactate clearance, and the athlete's ability to sustain prolonged exercise. However, the textbook also warns that excessive LSD training may shift type 2X muscle fibers toward more oxidative type 1 characteristics. So for this in-season cross-country runner, I would prescribe a continuous run lasting about 45 to 60 minutes. The intensity would be 70% of the VO2 max and 70% of a VO2 max of 75, which is his VO2 max, would be 52.5 milliliters kilograms per minute. Using the Karvonen method, 70% heart rate reserve, again, is approximately 157 beats per minute. So the target heart rate is about 77% of his max heart rate. On the traditional Borg rating of perceived exertion scale from 6 to 20, the effort should feel about 12 to 13, meaning light to somewhat hard. This would be one continuous training bout, so it would not have formal work and rest intervals. And the athlete should maintain a controlled pace, be able to speak in short sentences, and avoid allowing the session to become a race. Like, it's not for speed. Our second method is the pace or tempo training. The textbook describes pace or tempo training as exercise performed at or slightly above competition intensity and near the athlete's lactate threshold. A steady tempo session normally lasts about 20 to 30 minutes. And its main purposes are to improve running economy, increase lactate threshold, and teach the athlete to sustain race pace. The 17-year-old male athlete's lactate threshold occurs at 70% of the VO2 max, so I would prescribe the session at about 70 to 75% of the VO2 max. At 70%, his oxygen uptake would be about 52.5 milliliters per kilogram per minute, and at 75%, it would be about 56.3 milliliters per kilogram per minute. And using the heart rate reserve calculation, the target range would be about 157 beats per minute at 70% and 164 beats per minute at 75%. This corresponds to about 77 to 81% of the max heart rate. and his rating of perceived exertion should be about 13 of 15 on the Borg scale, ranging from somewhat hard to hard. And I would begin with a 10-minute easy warm-up, followed by 20 to 25 minutes of continuous tempo running, and then finish with a 10-minute cooldown. Because this is continuous tempo training, there is no formal rest period during the main portion. The athlete should select a pace that feels challenging but sustainable without a major decline in running mechanics. So our third method is the interval training. According to chapter 20 in the textbook, interval training is normally completed near VO2 max using work periods lasting about 3 to 5 minutes with a 1-to-1 work to rest ratio. This allows the athlete to accumulate more total time near VO2 max than would be possible during one continuous effort. It can improve VO2 max and anaerobic metabolism, but it should be used carefully and primarily with athletes who already possess an aerobic training base. So for this athlete, I would prescribe about 4 intervals of 4 minutes each. Intensity would be 90 to 95% of the VO2 max. And after doing the calculations, for 90% of the VO2 max, it would be 67.5 milliliters per kilogram per minute. And at 95, it would be 95%, it would be 71.25 milliliters per kilogram per minute. Using the Kurvonen method, the target heart rate range would be about 188 beats per minute at 90% heart rate reserve and 195 beats per minute at 95% heart rate reserve. This equals to about 92 to 96% of max heart rate, and the RPE should be about 17 to 18, meaning it's very hard. The session would include 4 minutes of work, 4 minutes of recovery, and 4 total sets. Again, the work ratio is 1-to-1. And recovery could involve very light walking or standing, depending on how the instructor interprets the relief interval. The main goal here is to recover enough to complete the next 4-minute interval at the prescribed intensity. Our fourth method is the high intensity interval training, or HIIT. HIIT involves repeated high intensity work bouts separated by relatively brief recovery periods. Chapter 20 explains that the athlete should accumulate several minutes above 90% of VO2 max to create an optimal stimulus. One example involves work intervals lasting 2 to 3 minutes near 90% of VO2 max, with relief intervals lasting 2 minutes or less. So for this athlete, I would prescribe 6 sets, 2 minutes of hard running, and 90 seconds to 2 minutes of recovery. Work to rest ratio should be about 1-to-1, although the recovery may be slightly shorter than the work period. Intensity would be about 90 to 95% of VO2 max, which is 67.5 to 71.3 milliliters per kilogram per minute. And using the heart rate reserve, the target range is 188 to 195 beats per minute, or 92 to 96% of max heart rate. The rate of perceived exertion is about 17 to 19, meaning it's very hard or extremely hard. Athletes should not perform this session every day. Want to make that clear. It does create significant physiological stress, so it should be separated from competition and other demanding workouts. Because this athlete is in season, I would avoid placing the HIIT sessions immediately before a cross-country meet. Our fifth method is fartlek training. Fartlek means speed play and combines continuous aerobic exercise with changes in pace. Chapter 20 describes fartlek training as easy running at about 70% of VO2 max, combined with hills or short, faster bursts at about 85 to 90% of VO2 max. It can improve VO2 max, lactate threshold, running economy, and fuel utilization. So for this athlete, I would prescribe a session lasting about 32 to 40 minutes. And one example can be 3 minutes of easy running, 1 minute of fast running, and repeat this sequence about 8 times. The fast to easy ratio would be 1 minute fast to 3 minute easy, or 1-to-3 ratio. During the easy portion, the athlete would run at about 70% of VO2 max. After doing those calculations, it would be about 52.3 milliliters per kilogram per minute, about 157 beats per minute using the heart rate reserve, 77% of maximum heart rate, and an RPE of about 12 to 13. During the faster portion, the athlete would increase to about 85 to 90% of VO2 max. At 85%, the oxygen uptake is 63.8 milliliters per kilogram per minute, and the target heart rate is about 180 beats per minute. At 90%, the oxygen uptake is 67.5 milliliters per kilogram per minute, and the target heart rate is about 188 beats per minute. This equals about 89 to 92% of the max heart rate with an RPE of about 16 to 18. So unlike traditional interval training, the athlete does not completely stop during the recovery period. The slower running serves as active recovery. This method is useful for cross country because the athlete naturally experiences hills, changes in terrain, surges, and changes in race pace. So for the weekly application, I would not prescribe all 5 of these demanding workouts during the same week. Because this athlete is beginning the in-season, the program must be arranged around cross-country meets and school practices. So a sample week could be Monday, an easy LSD or recovery run. Tuesday, pace or tempo training. Wednesday, easier running or resistance training. Thursday, interval, HIIT or fartlek training. Friday, it could be short and low intensity pre-meet session. Saturday, competition. And then Sunday, rest or active recovery. The interval, HIIT, and fartlek sessions could rotate from week to week rather than all being performed during the same training week. And the textbook does explain that training intensity, duration, and frequency interact. As intensity increases, duration normally decreases. Progression should also be gradual, and frequency, intensity, or duration should generally not increase by more than 10% per week. So in conclusion, the 5 aerobic endurance training methods produce different training stresses and adaptations. Long slow distance training, LSD, develops the athlete's aerobic base and ability to sustain prolonged running. Pace or tempo training improves lactic threshold and the ability to maintain race pace. Interval training allows the athlete to accumulate time near VO2 max through 3 to 5 minute repetitions and equal recovery periods. The HIIT, high intensity interval training, uses shorter, highly demanding work periods to improve high intensity aerobic performance. And the fartlek training combines continuous running with a planned or unplanned changes in pace, making it especially useful for cross-country athletes. So for this 17-year-old, the estimated max heart rate was 203 beats per minute. Heart rate reserve was 155 beats per minute, and the target heart rate can be calculated using the Kervonen method. Because the athlete is in season, each session should be coordinated with competitions, resistance training, recovery, and the athlete's overall workload. The goal here is to improve performance without creating excessive fatigue or overtraining. Thank you for watching my presentation.